Hey everyone, today my team and I are going to be presenting a project which is named ReviewPulse AI. So my team consists of myself, Raghav, and Piyush. So our project ReviewPulse AI is a cross-platform product review intelligence system. We designed it as a data-first engineering project that collects review data from multiple sources, transforms the data into a shared schema, enriches it with analytics, and then makes it searchable and explainable through a user interface application. The main problem we wanted to solve is that the reviews are fragmented across platforms. If someone wants to understand what users are saying about quality, service, value, or complaints, that information is spread out and each platform stores it differently. So instead of starting with a chatbot, we started with a data architecture problem itself. That was important for us because we wanted to build an interface. The main challenge in this interface is understanding the data deeply, the inputs, the schemas, the missing fields and transformation, and the relationship between the pieces of the system. So our project focuses heavily on ingestion, normalization, processing, and validation. In our MVP, we worked with multiple sources. We used Amazon review sample data, the real Yelp open data set, Reddit style discussion data in prototype form, and YouTube transcript style review data in prototype form. The scale story is also important here. So Amazon Reviews 23 is a very large academic review data set with 571.54 million reviews across 33 domains, and Yelp's official open data set is 8.65 GB uncompressed, which makes this a strong fit for us to move forward with our application. What made this challenging is that these sources are not naturally compatible. Amazon has star ratings and verified purchase fields. Yelp has star ratings but no verified purchase concept. Reddit has scores and discussion text but no star rating at all. YouTube transcripts are unstructured text and do not have a review rating field. So we had to decide very carefully how to normalize these sources without inventing information that does not exist. One example of that data design is our handling of ratings. For Amazon and Yelp, we normalize ratings into common 0 to 1 scale, but for Reddit and YouTube, we keep ratings as null because these platforms do not have a true star rating system. That decision may sound null because those platforms do not have a true star rating system. That decision also was very helpful for our project as well. So the main contribution of the first part of the project is this. So we built a multi-source ingestion and normalization workflow and then turns fragmented review data into structured data set that can be processed consistently downstream. So moving forward, Raghav would be explaining.
Thank you, Ayush.
Yeah.
So I'll explain the architecture and processing pipeline. Our system has several layers. First, we have the source ingestion layer that includes our source specific scripts for preparing or collecting the input data. Second, we have the normalization layer where each source is converted into a shared schema. Third, we have the Spark processing layer, which writes analytical Parquet outputs. Fourth, we have enrichment and retrieval, including sentiment scoring, embeddings, and vector storage. Finally, we have the application layer, which exposes the system through an API and dashboard. At the center of the system is the unified review schema. Every normalized record includes fields like review ID, source, product or business identifier, raw text, review date, sentiment fields, and source metadata. We also added cleaner display metadata like in a human readable way in the front end and in the grounded answers. So the metadata like display name, display category, entity type, so that the same underlying data can be presented in a more human readable way. After source level normalization, we built a Spark based normalization pipeline. This was an important part of the project because we did not want Spark to appear in the proposal only as a buzzword. We actually implemented a PySpark job that reads the input data, standardizes the fields, unions the sources into one dataset, computes summary statistics, and writes Parquet output for the rest of the application. From there, we built a sentiment scoring stage. In the current MVP, this is a lightweight baseline sentiment layer that enriches each review with a label and a numeric score. It is not meant to be a final production sentiment model, but it provides structured signals that support analytical and retrieval. This lets us compute sentiment breakdowns by source and expose those metrics in the front end. The next layer is semantic retrieval. We take the processed review text, generate embeddings using a sentence transformer model, and store those embeddings in ChromaDB. This enables semantic search rather than keyword only search. That means a user can ask a natural language question and retrieve reviews that are meaningfully related, even if the wordings does not match exactly. Then we build the API layer with API layer with the fast API. The backend exposes endpoints for health checks, source level statistics, semantic retrieval, and grounded chat. The important idea here is that the answer generation layer does not operate on general model memory. It retrieves supported review text first, and then answer is generated only from that retrieved evidence. If the external model is unavailable, the system falls back to an extractive grounded answer instead of failing completely. We also pay attention to testing and validation. We wrote normalization tests to verify source specific logic, null handling, and schema consistency. That was important to us because the project is not just about getting outputs on screen, it is also about proving that the data pipeline behaves correctly and that we understand what each transformation is doing. So architecturally, the project is end-to-end data system. It starts with heterogeneous raw review sources, moves through normalization and Spark processing, adds enrichment and retrieval, and then exposes the results through APIs and the front end. Now I'll pass it on to Piyush.
Thank you, Raghav. And now I'll discuss and walk through the application, the correct MVP results. On the front end, we have built Streamlit dashboard that sits on top of Fast API backend. The application has two main purposes. First, it gives user high-level analytics about data sets. Second, it lets the user ask grounded questions and inspect supporting evidence. In the application, the upper part of the page is main interaction flow. The user asks question and optionally filters by source. Uh, Second, it lets the user ask grounded questions and inspect the supporting evidence. Uh, the lower part of the page focuses on analytics. It shows overall review counts, source counts, and sentiment breakdown. So the app is not only a question answering interface, it also is a review analytics dashboard backed by the data pipeline. If you walk through the flow, the user first enters the question such as what do reviews say about if I have to try it out. Yeah. Okay. So if I have to put the query, what do reviews say about customer service? And if we put the source as Amazon and put 5 as the limit, and if we execute the result, we see the output running around. So it gives like 5 outputs that are related based on the evidence of what we have already asked the chatbot, and it gives out a relevant result. This proves that whatever result is generated in this is relevant to the products mentioned in that we have already implemented through the data set that we have already captured through the Amazon data set that is around 75 gigabytes of data. If we walk through the flow, the user first enters question like the one I entered, and the backend database uh, takes the input and produces an answer that is grounded in those retrieval records. The answer is displayed along with the citations and supporting review snippets as shown underneath. One thing we want to be honest about is that not every source is equally mature in the current MVP. Yelp is our strongest real source right now because it uses the real Yelp dataset and gives the richer natural text because of the Yelp open dataset that we use. In terms of the structurally correct term, the pipeline, it also follows simple style review text so that Amazon answers are technically grounded as well as that of Yelp. And the limitation of Amazon right now currently that we are facing is that we have basically taken the sample dataset into consideration, and we'll be implementing the later part of the dataset later in while we are building the application. Even with the limitations, the core system is working end to end, and We can ingest multiple sources and normalize them, process them with Spark, enrich them with sentiment, and build embeddings, perform semantic retrieval, and expose the results through a backend and user-facing application. That is the main success of the MVP right now. So to summarize the outcome, ReviewPulse AI is not just a chatbot and not just a dashboard. It is a full workflow that starts with a raw multi-source review data and ends with a user-facing product building on top of structured processing, retrieval, and grounded answers. We believe that combination of data architecture, processing, validation, and controlled LLM usage is the strongest part of the project. And we would like to thank you all for viewing us. Thank you so much.
Thank you.